Let's move to vectors which are not unit vectors. We have these two vectors, A vector and B vector. This is 2i cap plus 3j cap plus 4k cap, and B vector is I cap plus 2j cap plus 3k cap. Now let's find the cross product, A vector cross B vector, and I'm going to show you what the cross product is, and then we'll see together where that comes from. So A vector cross B vector, that's equal to the determinant of I cap, j cap, k cap, 2, 3, 4, that's 2, 3, 4, and then 1, 2, and 3. This is 1, 2, and 3. So I cap, j cap, k cap, the components of A vector and the components of B vector. The resultant of this determinant is going to give us A vector cross B vector. So let's find it. So let's open it from the first row. I cap times 9 minus 8 minus j cap times 6 minus 4 plus k cap times 4 minus 3. So this is I cap minus 2j cap plus k cap. So this is the cross product of A and B. This vector is going to be perpendicular to both A and B. Now where did this come from? Let's understand. Similar to dot product, we use distributivity and multiplying with a scalar. Distributivity says A vector cross B vector plus C vector, that's equal to A vector cross B vector plus A vector cross C vector. This works the same as what we see in real numbers. A times B plus C is equal to A times B plus A times C. And multiplying with the scalar means that the constant, this real number, can come out. A vector cross lambda B vector, that's equal to lambda times A vector cross B vector. So the lambda can come out. Using these two and whatever we know about the unit vectors, we can now evaluate A vector cross B vector. So let's do that. A vector cross B vector. So let's take this term by term. The first is 2i cap cross I cap. So that's 2 times I cap cross I cap. Then we have 2i cap cross 2j cap. That's 2 times 2, 4. I cap cross j cap. Then we have 2 times 3, 6. I cap cross k cap. Then we have 3 j cap cross I cap. 6 j cap cross j cap. 9 j cap cross k cap. 3 more. 4 k cap cross I cap. 8 k cap cross j cap, and 12 k cap cross k cap. Now some of these are 0, some of these are easy to evaluate. Pause the video, take this forward. Okay, so the first one, I cap cross I cap, that's 0. This is also 0, and this is also 0. These are collinear vectors. For the rest of them, we'll get some value. So this is 0. I cap cross j cap, that's k cap. So this is 4 k cap. I cross k, that's minus j, so this is minus 6 j cap. J cross I, that's minus k, so that's minus 3 k cap. This is 0. J cross k is I, so that's 9 I cap. K cross I is j, that's 4 j cap. K cross j is minus I, so that's minus 8 I cap. And this again is 0. So if you sum all of them, you will get 9 minus 8 I cap, 9 minus 8 I cap, minus 6 minus 4 j cap, minus 6 minus 4 j cap, plus 4 minus 3 k cap, plus 4 minus 3 k cap. So you got the exact same result. Now we can write this in determinant form, and this is how we prove that this works. In general, if you have two vectors A vector and B vector, and they are A1 I cap plus A2 j cap plus A3 k cap, and B1 I cap plus B2 j cap plus B3 k cap, their cross product can be written as this. Determinant of I, j, k, A1, A2, A3, B1, B2, B3. Now before we wrap up, let's quickly look at why the distributivity works for cross products. So we have to prove that the distributive property of cross product over addition works. A cross B plus C is equal to A cross B plus A cross C. Let's take some generic vectors. A vector is A1 I cap plus A2 j cap plus A3 k cap. B vector has B1, B2, B3, and C vector has C1, C2, and C3. Now let's take B plus C first. So B plus C is B1 plus C1 I cap plus B2 plus C2 j cap plus B3 plus C3 k cap. Now let's take the cross product of A with B plus C. So A cross B plus C, that's going to be the determinant of I, j, k, A1, A2, A3, B1 plus C1, B2 plus C2, B3 plus C3. And here we can split this determinant at row 3. We have I, j, k, A1, A2, A3, B1, B2, B3, this determinant plus I, j, k, A1, A2, A3, C1, C2, C3. So this determinant is the sum of these two. And look at this. This is the cross product of A and B, and this is the cross product of A and C. So this is how we can prove that A cross B plus C is equal to A cross B plus A cross C.